Well, hello there. My name is Borna, and if you're also fascinated with marine life, you're going to enjoy this cool story I'm about to tell you about corals and how scientists used calculators and powers of 10 to study them. Have you ever thought to yourself, oh wow, corals are so beautiful. Where do they get their different colors from? Well, corals are animals. Yeah, you heard that right. Corals are animals. And inside the coral animal cell, there are single-celled algae that give them their cool colors. But algae does way more than just adding cool colors to corals. They are actually crucial to the survival of corals. They help corals go from this to this. Think of each coral animal as an apartment and the algae as the renter. The algae pay rent by providing the corals with yummy nutrients that the algae get through photosynthesis. But unfortunately, as sea surface temperatures rise due to climate change, the algae become less able to provide nutrients to the coral. This is known as coral bleaching because without the algae, the corals look pure white, and it can lead to widespread coral death. Coral bleaching has been getting worse, and this can lead to the extinction of various coral species. In this cool paper, scientists intentionally evolved algae in the lab that are more tolerant to heat. They discovered that some of the strains of the algae had evolved the ability to grow in high heat. This graph shows how much different strains of evolved algae grew in high temperatures. But what do these numbers next to the y-axis mean? Okay, so let's say you just won the lottery and the total dollar amount is... Did you just win 5 million or 50 million? Let's look again. 1, 2, 3. So that's 7 zeros, so 50 million. But you'll have to count all the zeros. And if you're even off by 1 zero, you can think you won 5 million or 500 million. That's a big mistake. Scientific notation allows us to express numbers with a lot of zeros without having to count all the zeros every time. It is easy once you get what's going on. In scientific notation, all we're doing is moving the decimal point and then multiplying the desired number by 10 to the number of times that we have moved the decimal point. The first thing you do is move the decimal point until there is one number left to the left side of the decimal point. Be sure to count every time that you move the decimal point. For example, to express 50,000 in scientific notation, we would need to move the decimal point 4 times. And then we can rewrite the number as 5 times 10 to the 4. Here's another example. Let's express 7,320,000,000 in scientific notation. We would need to move the decimal point 9 times. So we get 7.32 times 10 to the 9. Now you see why we use scientific notation? But what if we have a really small number, like 0.00089? We can still use scientific notation, because look, there's still a lot of zeros. But in this case, we need to move the decimal point to the right side. And when we do that, the exponent will be negative. So we will need to move the decimal point 4 times to the right. And we can rewrite the number as 8.9 times 10 to the negative 4. Now, check this out. That negative is very important. And here's why. 7.45 times 10 to the 3 equals 7,450. But 7.45 times 10 to the negative 3 equals 0.00745. So remember, whenever you move the decimal point to the left, the power of 10 will be positive. And whenever you move the decimal point to the right, the power of 10 will be negative. When reading numbers in scientific notation, when you see numbers like this, you can tell it is a huge number because of the positive exponent. And when you see numbers like this, you can tell it's a tiny number because of the negative exponent. Now that you know how to express numbers in scientific notation, let me show you how to put them in a calculator. If you're using a scientific calculator or if you're using spreadsheets like Excel or Google, there are 2 ways to type in the powers of 10. The first way is just to put in the whole expression. So 7.45 times 10 to the power of 5. The second way is by using the letter E. If you are using a TI 83 or 84, you can get to E by using second comma. If we're using E, we'll have to type in 7.45 E, 5, which gives us the same number. Some calculators use E plus or E minus instead of times 10 to the or the capital E on your TI 83 or 84. It's the same concept, but it just looks a little bit different. For example, 7.45 times 10 to the power of 5 will be rewritten as 7.45 E plus 5. Remember the cool paper I mentioned earlier? Well, the scientists were working with multiple step operations to calculate the cell density of the algae. But how do you use a calculator to calculate multiple step operations? You might think this is a trick question, but there are specific steps that need to be followed in order to get an accurate number. Parentheses let your calculator know which numbers belong to the same operation. For example, let's say you want to use a TI 83 or 84 to calculate this number. Use parentheses to separate the operations in the numerator from operations in the denominator, like this. Remember, please excuse my dear Aunt Sally. Finding the value inside of the parentheses is the first step to solving a multiple step operation. And in this example, the calculator applies the division before adding or subtracting, which gives us a very wrong answer. Always remember to close your parentheses, otherwise you may not get an accurate result. With this knowledge, sky's the limit. You can calculate the cell density of algae like the scientists in this cool paper, or you can calculate the gravitational force between the Earth and the Sun, or you can convert between moles and grams. Now, get out there and crunch them numbers. And someday, you can also find ways to help save planet Earth. And remember, whenever in doubt, just add parentheses.